Greetings from Hinterlands headquarters. This is Conor O'Shea. In this software tutorial, I'm going to demonstrate how to import a digital elevation model into ArcGIS Pro and to cut 1-foot contours from that digital elevation model, then export those into a DWG file, open that up in Rhino, and then using Grasshopper and the LandKit plugin from Chris Landau to generate a mesh from those contours and then do an elevation analysis that visualizes the Z value range of that mesh. So you're going to need ArcGIS Pro for this, you're going to need Rhino, and you're going to need Grasshopper. This is an example of the contours that we will be generating using ArcGIS Pro. And here is an example of what your mesh will look like inside of Rhino and your Grasshopper script on the left that you'll use to generate that mesh. The first thing I'm going to do here is open up a ArcGIS profile that I've been working with already. And what you're looking at here is the state boundary of Illinois. We're looking at some level 3 ecoregions, and then in the orange symbols, the orange crosses there, those are regal fritillary butterfly sightings. It's a data set that was downloaded from iNaturalist. So for this tutorial, you just need some sort of base file up and running from which to bring in a digital elevation model and then cut contours. So let's go ahead and do that. First thing we're going to do is we're going to go over to our catalog pane, and we are going to select the ArcGIS Online portal. And inside there, we want to search for IL_statewide LiDAR. And that's the name of the file we're eventually going to get. But you can actually just search for your state and then LiDAR. And if you're using Illinois, you'll be able to pull up this one here. And what you want to do is you want to go ahead and right-click on that and then just say Add to Current Map. So it's going to go ahead and add that over here. And we can see here that it's actually underneath our ecoregion layer, so we're going to turn that off. It takes a little while for this to draw because it's pretty complex, but here you go. You can see the whole thing. And for the purpose of this tutorial, we want to zoom in on an area that's near these butterfly sightings, because the idea is we're going to be thinking about how we might transform some land that's near these. So we just want to go zoom in to an area that's pretty close to these existing butterfly sightings. The next thing we want to do is we need to create a feature class so that we can create a new polygon, essentially a boundary that we'll use as an input to crop out the contour layer that we'll generate from the digital elevation model. So to do that, go to your project pane in the project tab inside your catalog pane, go to databases, and then for the geodatabase for your project, you want to right-click on that and go to New, and then you want to go to Feature Class. And once you're in here, you want to give it a name. And so this we're just going to call, why don't we call it DEM boundary. And I'll go ahead and just hit next. It'll be a polygon feature. Hit next, 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 and then I'll hit finish. And we'll just ignore that error for now because we see that the DEM boundary layer has automatically been added over here on the left. Okay, now that we've got this DEM boundary, we are going to draw a new polygon. But first, I want to select an area. And we're going to use an area of about 150 acres. And that's related to the ecology of the regal fritillary butterfly. So you can, if you're following along this video in relation to the regal fritillary, you can choose a size that's suitable for the butterfly, or you can just choose any boundary that's suitable for the project that you happen to be working on. So I want to go ahead and I want to add a imagery hybrid base layer that I can zoom in on just to kind of get a sense of the scale here. So we've got the roads over an aerial, and I want to choose an area that is both near the regal fritillary, but that also has some topography change. And so these areas right here actually look like they're pretty suitable. I think I might choose something right around here where this agricultural land abuts these small creeks. So I think something right around here might be nice. So now that we've got that figured out, I'm going to go over to DEM boundary. I'm going to click on that. Then I'm going to go up to edit, and I'm going to click on the create button. And over here on the right, the create features pane is going to pop up. And I am going to select on DEM boundary because that's the layer that we want to draw on. And I'm going to choose right angle polygon. And then over here on the drawing, I'm basically going to draw a square. And so we want to create a square that is 150 acres. And so to do that, we need to draw a square that is about 2,556 feet by 2,556 feet. If you have questions about how I calculated that, just drop some questions in the comment section here. But I'm going to go ahead and click once here, maybe here near this creek. And then I'm going to right click. And this is going to pull up all these different options here. And I want to do the distance option. And I'm going to put in the exact number of feet that I want this side to be. So 2,556. I'm going to hit enter. And you can see that it's automatically limiting the length of this line to that distance. I'm going to click. And then I'm going to right click again. And I'm going to put in direction distance. Nope, just right click and do distance. And 2,556. Enter. And then click once more. Whoops, Control Z, right click, distance, 2,556, enter. And I will click and hit enter. Enter again, and then down here, just click the green check mark. Once I'm done doing that, I've got my square that I'm going to use to export, and I'm going to go ahead and click Save up here on the Edit ribbon, and to save my edits to this feature class. And I'll hit Yes. And I'll be all set for the next step. Okay, the next thing I'm going to do is I'm just going to change the symbology of this over here. I don't really have to do that, but I want to be able to see through it. But the next thing we want to do is we need to actually cut some contours. So the way to do that is to go to your geoprocessing pane over here. If that is not up for you, you can just go to let's see, analysis, and click on tools. I think that should pull that up. But if you go to the geoprocessing, you can actually just type in contour, and it'll pull up some different options. So what we want to do is we want to create a feature class of contours from a raster surface. So we can go ahead and select this first one. Click on that. Now the input raster is going to be the statewide LiDAR. You guessed it. The output feature class is giving us that name, so let's just go ahead and keep that. The contour interval is going to be 1, so that's going to be in feet, so we want 1 foot contours. If we go over here to environments, this is where we are able to put in a boundary. And so to do that, we need to go under the processing extent options here and click on this layer menu, and we want to go ahead and select the feature class that we just created. So let's do DEM boundary. And so that'll be basically the clipping mask for generating the contours. Otherwise, it would generate contours from the DEM for the entire state, which would take a long time, and we don't need all that data. So we're going to go ahead after doing all this and hit run. And I will go ahead and pause the recording until it's done generating those contours. Okay, it only actually took a few seconds, but as you can see over here, it's gone ahead and it's added these contours at a 1 foot interval to our map here, and it's automatically given them this purple symbology for the line, and you can go ahead and change that if you want, but we're going to be exporting this momentarily. So once you've got that, we want to go ahead and go back to our geoprocessing pane, and we want to export to DWG. So to do that, why don't we just go ahead and type in DWG, and we'll see this export to CAD option. So go ahead and click on that. The input features are going to be Contour Illinois Stat2, so that's what we just did. And the output file is going to be automatically generated. It just takes the feature class name _ export CAD DWG. So go ahead and put that in a location that works for you. And then when you're ready, just go ahead and click on the Run button. Okay, so now you're all done. You've got your CAD file exported, and you're ready to go on to the next step. Now you want to go ahead and fire up Rhino and select the large objects, inches, feet, and inches template. Once you've done that, go ahead and click Open. Once your file is open, you can go ahead and type in import. And then you want to go ahead and navigate to where you saved that export. So I'm going to go ahead and hit enter on this. The model units should be set to, let's go ahead and do feet, and then go ahead and hit OK. And we don't see anything, and that's because the model is not near 0, 0. So let's activate the perspective window. Let's type in zoom up here in the command line, and let's type in E to go to zoom extents. And it's going to go out here, and we can see all these contours that have just come in, which is pretty great. Now we want to verify the size of this, and essentially what's going on here is the vertical dimension, the Z value, are in feet. So to double check that, we can type bounding box into the command line. Let's select everything. Let's hit enter. Hit enter again, and we have this box here. So let's measure the distance here. So the vertical distance here is 75 feet, which seems reasonable. We'll double check that in a second. But if we check the distance of either this side or the other side, we see that it's 790 feet. Now this is actually too small because, as we know, we created sides that were 2,500 something feet. So we're gonna need to resize those. And essentially what it's done here is it's brought in the meters and it's reading them as single units, as feet. But just to verify the contour elevation range, why don't we go ahead and click on the contour layer that was generated over here, and then we want to actually label this layer, and we want to label it using the contour number. So let's go ahead and click label, and let's give it a second to generate these numbers. And maybe while it's doing that, we can also look at it a different way. We can open the attribute table, and we can see actually the range here. So 542, let's sort ascending. 542 all the way to 617, and we can see that reflected in the labels. So that seems reasonable what we have here, but we're going to need to change the scale of this. And so to do so, we're actually going to have to multiply each side. We're going to scale the whole thing by 3.28, so the number of feet that are in a single meter. So to do that, you want to use the scale 2D command, not scale 3D, because that'll scale the vertical dimension as well. We want to scale on the X and Y dimension by using scale 2D. Let's go ahead and select everything, hit enter, and we'll scale. We'll use this as our base point, and we're just going to go in one direction here, and I'm just going to type in 3.28 and hit enter, and hit, yeah, don't need to hit it again. And then just to verify the distance here, we've got 2,591. So it's more than what we put in ArcGIS, but it's possible that It's possible that something got adjusted in that process of drawing the polygon. It may have had something to do with the way that it drew that polygon in the coordinate system in the file. So I think for our purposes, this is close enough. One other thing that you want to do is we actually want to move this to our 0, 0 point. That'll be much easier to work with there. So let's choose this corner, which I think is the origin point. And then we're going to move it to 0, 0, 0. So this will move it in the X, Y, and Z axes. We don't see it anymore, so we can type in zoom, E, the shortcut for extents, and it'll go back to 0, 0. And we can see that indeed it is right where we need it to be. Next up, we want to fire up Grasshopper. And we're going to use Grasshopper to actually generate a mesh of this surface. Okay, I have Grasshopper open here, and I've arranged my windows so I have Grasshopper on the left and Rhino on the right, which is the way I like to work. I want to go ahead and make sure that this bounding box is on its own layer. So let's just confirm that. It says it's on layer default. Let's rename layer 1 bounding box, and then we'll change this to bounding box. Okay, that's good. And we maybe don't actually need that on anymore, so I'll go ahead and turn that off. We've got our contours over here on the layer that they were imported on. So first thing I want to do is I want to fire up bifocals. Bifocals is an essential Grasshopper plugin. There's a short YouTube tutorial on this on my channel if you want to check that out. And then what we want to do is we want to create a geometry pipeline. And the geometry pipeline is basically going to collect all of the data from our contour layer and bring it into this definition. Now, the next couple components that we need are actually from a plugin for Grasshopper called LandKit. And LandKit is available as a pro version, and it's also available there's a free version available on Food for Rhino. You can read all about it here. It's by Chris Landau. You can go to their website and check out all the features. They have amazing tutorials on YouTube, stuff on their website. But we're going to be using some of the components from that on here. They have a set of tools that are specifically for plants. They also have one that is specifically for water, and then another set of tools that are specifically for topography. So we're going to be using the topography one. So go ahead and go to Food for Rhino, download this, and install it, and then you'll be able to proceed to this next step. So you got your geometry pipeline here. We want to actually double-click on here because that'll allow us to bring in all of these curves. And then what you'll see once you download LandKit is you'll see a topo kit, a water kit, and a paving kit up here. And there should be a planting kit as well. Oh yeah, there's the plant kit. But for now, we're going to use a topo kit. And the first thing that we want to bring in is this component here called add to geo set. And we want to connect this to contour curves. And once we've got that, let me go ahead and turn off this preview. Once we've got those connected, we want to go ahead and use this create topo component and go ahead and connect those two. And then we want to draw the topo. So to draw the topo, we want to use this component. Let's go ahead and connect the output here, which is a topo instance, into here. And what that's going to do is it's going to create a mesh and also a series of points. So it may take a little while for this to run for you. It's taking a little bit of time for me, so I'm going to go ahead and pause the recording while it does that. Okay, it only took about a minute or so. You can see here, well, I guess 41 seconds, to be more precise. I'm actually going to end up turning that preview off in a second. But the last thing we're going to use for this tutorial here is the analysis component, which has a couple different parameters as inputs, but for now we're just going to use the mesh as an input. It's going to take a little while for that to run as well. So I'll pause the record. Oh, there we go. 5.2 seconds. I'm going to go ahead and turn off the preview for Draw Topo and these other ones as well. And okay, that's where this is coming from. So now we can see that we've got a mesh that is generated using Topo kit from Chris Landau's LandKit. And then we're also using this elevation analysis to show the kind of the high points and the low points in here, which if you go back to your ArcGIS profile, you can see is pretty consistent with what's going on in there. So I hope you enjoyed this. If you have any questions or clarifications, please feel free to leave some comments below, and I can try and respond to those. Or if you have any tips on how you might customize this workflow for your own purposes, you want to share with this realm of YouTube, please feel free to do so. But thanks so much. I hope you enjoyed this.